As I mentioned, we're skipping this for today. We'll cover the quadrilateral family tree tomorrow. We're starting here 6-2 and 6-3. 6-2 is what we're covering today, so we're going to cover the first part of this. So here we go. Parallelogram is a word I know you've heard before, and you definitely recognize that shape as well. A parallelogram looks like this. And I'm leaving these lines open because I'm going to write a definition there. But this is a parallelogram. Whoa, it's blurry. No. There we go. Okay. The definition for a parallelogram is it's a quadrilateral, so four-sided shape. And as I write this out, I'm going to be identifying abbreviations I'm going to use later on. So quadrilateral, instead of having you write that out every single time, we're going to abbreviate that as quad, period. Quadrilateral with both pairs of opposite. Opposite's another word that we're going to abbreviate as OPP, period. Opposite sides parallel. And then parallel already has an abbreviation. It is these two lines like this. That's the abbreviation for parallel. So parallelogram, by definition, is a quadrilateral with both pairs of opposite sides parallel. What does that mean? Well, it means that the opposite sides are parallel. So this side is parallel to this one. And that's what these little arrows mean, is if it has the matching number of arrows, those are parallel. And then this side is parallel to this one. If we were to name this parallelogram, we would say that this is parallelogram A, B, C, D. Okay, so now we're going to look at the theorems associated with parallelograms. These are all things that are true for any parallelogram. Just to kind of show you up in the family tree, a parallelogram has opposite sides parallel by definition, so that means that a rectangle would also be a parallelogram, so would a square, and so would a rhombus. So that's what I'm going to be going over tomorrow, but just to kind of give you a visual, so a rectangle is a parallelogram, a square is a parallelogram, and so is a rhombus. So all the things we talk about for parallelogram also apply to these three shapes. So here's the first theorem. Opposite sides of a parallelogram are congruent. So I'm using a lot of abbreviations. This is why if you ever miss a lesson, it's important that you're also listening to the lesson, not just watching it on a screen, because without the explanation, it'd be hard to figure out what that actually means. So opposite sides of a parallelogram are congruent, and what that looks like is if you have a parallelogram, that means this side would be the same length as its opposite, and this would be the same length as its opposite over here. Number 2, opposite angles of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. So I'm going to draw a little picture here. So opposite angles are like diagonal. So this angle is the same measure as this one. And this angle is the same measure as this one. And the next one, consecutive angles are supplementary. Consecutive angles are supplementary, meaning they add to 180 degrees. So I'm going to draw a little picture here. So x plus y equals 180 degrees, no matter how you look at it. And that makes sense in terms of like parallel lines and a transversal. So for example, if these were parallel lines, which they're parallel, and then this was a transversal, the consecutive interior angles were supplementary. So it also holds true for parallelograms. The fourth one, if a parallelogram has one right angle, it has four right angles. If a parallelogram has one right angle, hello abbreviations, then it has four right angles. And here's the picture here, which makes sense. Like if this is 90 degrees, then this has to be supplementary to it, so it would be 90 degrees. Your opposite angles are congruent, so everything would have to be 90 degrees, so it would be a rectangle or a square. Okay. 5 through 8 I'm going to cover tomorrow. But there's one I forgot. I don't know if I forgot to put it in the list or whatnot, but you do need to know it, and it's this one. I'm going to write it off to the side. Diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other. So what that means is if you have a parallelogram, the diagonal would go across like this. These diagonals are not the same length. If you'll notice, one's a lot shorter than the other, but they do bisect each other, meaning that this is the same length as this. This is a midpoint of this segment. And then for this one, that intersection is the midpoint of that segment. Okay, so now we're going to transition over to the workbook so we can practice this in problems.